Okay, guys, I'm going to try to work through some of the problems on the review to help you with. We did problem 1 on the board today, so was on board. So I'm going to jump to problem number 2. So problem number 2, we have the experiment is guessing the gender of the 3 children in the family, and the event is that the family has 2 boys. So the first part is we're going to create that tree diagram. And so I have the family either has a girl or a boy, and then that's their first child. And then their second child is either going to be a girl or a boy, or a girl or a boy. And then the third child can either be a girl, a boy, girl, boy, girl, boy, girl, boy. Okay, so now that we've created our tree diagram, we're going to list out our sample space. So sample space equals, and then we're going to use that curly brace, and then we're just going to list out all of that possibilities. So girl, 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 boy, girl, boy, girl, girl, boy, boy, then we have boy, girl, girl, and then we have boy, girl, boy, and then we have boy, boy, girl, and then we have boy, boy, boy. Okay, so I just double counting to make sure that we had 8. That is what we're looking for. And then we're looking for the case that the family has 2 boys, just 2 boys. And so we see that they have 2 boys in this one. They have 2 boys here, and they have 2 boys here. So those are the only 3 cases where that happens. So our event can either be where they had a boy, a girl, and a boy, or a boy, boy, girl, where they just had, you saw what I did too. So this one they had more than 2 boys. So we have boy, 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 and so the other one's up here. And we see that it's girl, boy, boy. So again, we see that it's girl, boy, boy. Sorry about that. And then now we're doing number 3. And we see that it's the Virginia state license plate has 3 letters followed by 4 digits. Assuming that any letter in any order can be used, how many different license plates are possible? So you have a license plate, and in your license plate you have a letter, so 3 letters and 4 digits. So here we can fill it in with 26 letters in our alphabet. Again, we have 26 letters in our alphabet, 26 choices, and then from 0 to 9 we have 10. So we go 10 times 10 times 10 times 10. When we multiply all those together, we end up with 175 76 0 0 0 0. Okay, I'm going to scroll the page. Okay, so for number 4, we see that it's on the basis of prior accounts, the quality control officer says that there's a 0.05 probability that a randomly chosen part would be defective. And we know this is based on observations, so we're going to consider this to be empirical probability. The next one is the probability of rolling a 2 6-sided die and getting a sum greater than 1/6. The sum of the probability of rolling a die or dice and getting the sum greater than 9 is 1/6. And so this is based off of that classical probability. We know the chances of getting rolling each side of the die is just going to be 1/6. So based on that classical probability, we're able to say that. For number 6, we see what is the probability of randomly selecting a firm that will have at least 10 employees. So at least means they could have more. So we know that the probability of at least 10 equals 0.108 plus 0.098 plus 0.018. We're getting these from these values up here. So they could have had 10 to 19, 20 to 99, 100 or more. And when we combine all those and add them up, we get 0.215. So number 7, we're looking at the telephone numbers for a region of a state have an area code of 570. The next 7 digits represent the local telephone numbers for the region. The telephone number can begin with a 0 or a 1. Your cousin lives in the next area code or lives within the given area code. What is the probability of randomly generating your cousin's phone number? So your cousin only has one phone number. So there's only one option, and it's going to be out of the total number of numbers possible. So it cannot begin with a 0 or a 1. So that brings us from the original 10 to 8 for your beginning number. But the other 7 numbers, or the other 6 numbers of the digits, can be 10. Okay, now that I have that, I'm just going to perform that operation. If you're putting this into your calculator, you're going to want to make sure all of this is in the parentheses in the denominator. And we see that it's going to be 1.25 times 10 to the negative 7. So I'm going to guess you're probably not going to come up with your cousin's phone number on the first try. And the next group says the list shown shows the results of a study that has plus or minus grades in the North Carolina State University. It shows that the percentage of graduate and undergraduate students who received grades with pluses and minuses. So of all the students who received 1 or more plus grades, 92% were undergraduates and 8% were graduates. And then of all the students that received received 1 or more minus grades, 93% were undergraduates and 7% were graduates. So find the probability that the student is an undergraduate student given the student has a plus grade. So we see that the probability is undergrad given plus, and we know that we're going to go up to the one that we know that's a plus grade, so it has to be using this portion. And since it's a plus grade, we know that once it's plus grade, that if it's going to be undergraduate, it's going to be 92%, so that 0.92. The next one says decide whether the events are independent or dependent. So tossing a coin 4 times and getting heads, and then tossing it a 5th time and getting a head. Well, the effect of the first one is not going to change the probability of getting a head. It's still 0.5. So we're going to say this is independent. And then number 10, you were shopping and your roommate asked you to pick up some toothpaste and dental rinse. However, your roommate did not tell you which brands. You get to the store and there's 8 brands of toothpaste and 5 brands of dental rinse. What is the probability that you will choose the correct brand on both in the first try? So the probability correct toothpaste and correct dental rinse equals the probability of correct tooth times the probability of correct dental. And we know that the probability of the correct toothpaste, well, there's 8 options, so it's going to be 1 over 8. And the correct of the dental rinse is going to be 1 over 5 because there's 5 of those. We multiply those together and we end up with 0.025. So the randomly select jelly bean, you have event A, which is, okay, so randomly select a yellow jelly bean, randomly selecting a red jelly bean from a jar, and then randomly selecting a yellow jelly bean from the same jar. Well, we know that when you select that, you cannot select a red and a yellow at the same time, so we say that these are mutually exclusive. Because both events can't occur at the same time, and then we see that we have a card. It's randomly selected from a deck, and the probability that the card is between 4 and 8 is inclusive, or it's a club. So the probability that 4 through 8 or club. So the probability that between 4 and 8, we see that it's 4, 5, 6, 7, 8. There's 5 of those in 4 different suits. So that's going to be the probability of 4 through 8 plus the probability of it's a club. And then we have a chance of it being both, so it's probability that's 4 through 8 and a club. And then we know that this is going to be 20 over 52. And then in a suit, there is 13 cards of that color, and we have 52. And then the chance that it's both a club and between 4 and 8 is going to be that 5 over 52. And we get approximately 0.538. So I couldn't put a pie chart on here. I typed these up so you could see the values. So it says, find the probability that randomly selecting a school that has more than 600 students. So the probability of 600 or more equals the prob of 600 to 999, plus the probability of 1,000 or more. So the probability of being between 699, that comes from right here, more than 1,000, right there. So we have that 0.198 plus 0.300, which is going to give me that 0.498. So again, you'd be able to see that this was on a Pareto chart if we actually had the pictures from the book. I included it there in case you wanted to look at it, but instead I just typed the data. And we see that now we are looking for find the probability of randomly selecting a adult from the sample who feels that healthy foods have poor taste or is hard to find. It's not an excuse, you should still eat healthy. So probability, poor taste, or hard to find, equals probability of poor taste plus probability of hard to find. And here we see that if it's poor taste, it's going to be 60 out of 500, and the probability of it's hard to find is 55 out of 500, which equals 115 out of 500, or 0.00. Let's fix that. Or 0.23. So for 15, we see that 15 cyclists enter a race. How many ways can they finish first, second, and third? This is going to be a permutation because order matters. So we see that's going to be 15 permutation 3. You can use that button in your calculator, or you can use the formula, and we see it's 2,730. The next one is an employer must hire 2 people from a list of 13 applicants. How many ways can we choose the employer to choose these applicants from that group? So we have 13, choose 2. Again, you can use that button, so it's 78. And our last one is going to be a security code consists of 3 letters followed by 1 digit. The first letter cannot be A, B, or C. Find the probability of guessing the security code on the first trial. So you're guessing you have 1, correct? And then it can't be A, B, or C, so that's 26 minus 3. So that's going to give you that 23. And then we still have 2 more letters, so it's 26, 26, and then 1 number, which is 10, which equals 1 over 1,550, 480. Yeah, I definitely read that wrong. Sorry, guys. 0.00000064. Okay, so now we're through 17. We're on to number 18. So number 18, we see the probability that no defectives is, of all the calculators, we know that 3 are going to be defective. So all the possibilities is 200, and you want to pick 3 to check. Choose 3. And then you want them to be not defective, so the probability of that occurring is 197, because we know we have 3 defective, so 200 minus 3 is 197, and so we have choose 3, and that's going to give me 1, 2, 5, 4, 8, 9, 0, all over 1, 3, 1, 3, 4, 0, 0, which is approximately 0.955. And then the probability that they're all defective, is going to be, you're choosing 3 calculators and you want them all to be defective, so they all have to be there. And so the bottom is 200, choose 3 because it's out of the total again. And we see that ends up being 1 over that 1313400, which is approximately 0.000. 1, 2, 3, 4, 5, 6 zeros, so 3 more to go. 7, 6, 1. And then the probability at least 1 defective is 1 minus the probability of no defectives. So if you have no defectives, obviously you can't have at least 1. And so as long as you take that out, you'll have at least 1 defective or all defectives. And so we got that value above, so it's 1 minus 0.955, which equals 0.045. And then the same concept down here, we have the probability at least 1 non-defective. And so that is going to be 1 minus the probability of all defective. So in those cases, the probability of no defective and the probability of all defective, when we consider those, you can't have what you're looking for because you want at least 1. And there's no way to have at least 1 non-defective calculator and the probability of all defective. So it's going to be 1 minus 0.000000761, which is approximately 0.999999239. Okay, so I counted those. It looks right. I erased the 9s though, so sorry about that. Okay, decide whether the pumps at the gas station is discrete or continuous. The number of pumps at the gas station, we know that this has to be discrete because there's a counting number for it. Discrete. And then over here represents the weight of a truck. Well, you can have decimals, so we say this is continuous. Down below, we want to decide whether the distribution, probability distribution. If it's not, identify the probability that's not satisfied. So we're going to look at this, and the easiest thing to check first is adding up all these values. So if I add up 0.36 plus 0.23 plus 0.08 plus 0.14 plus 0.29, we're going to end up with 1.1. And we know the probabilities has to be equal to 1. So we say no, it is not. Is the sum of the probabilities equals, it's not equal 1. Okay, so I'm not sure if I'm going to continue on because I'm on my lunch break. I'm not sure if I have time. So I'm going to pause here, and I'll probably try to pick this up later. I can try to do 23 right now. So if we go to 23, we want to find that expected value. So equals mu, which we know is going to be the sum of x times p of x And so then what I did was I multiplied x times p of x, and I created another column. I'm going to write it above, x p of x. And when I did this, the values I got were 1/9, 2/3, 3/2, 4/18. So I'm just multiplying these two columns together, and then I add them up to perform that sum operation. It gives me 2.5. So the value down here, we have that 2.5. 24 asks, decide whether the experiment is a binomial experiment or not. If not, explain. So a bag of plain M&Ms contains 24% blue candies. One candy is selected from the bag. The random variable represents the number of blue candies. So is this binomial? Yes, because we have successes, and the successes are not changed. They're independent, and we see that n equals 12, p equals 0.24. So q is 1 minus 0.24, which is going to equal 0.76. And then x can be 0, 1, 2, ... all the way up to 12. And then 25, we have the probability of getting exactly 3. So you have 8, choose 3. This is just using that formula. Probability of it being true is 25%. 3, 0.75. All that aren't true are failures. So we have, or aren't successes, are failures. So 8 minus 3, which is going to give that to be equal to 5. And we get 0.208. The probability of x being greater than or equal to 3 equals 1 minus the probability of x being less than 3. When I work these out, you guys can do it too. Just use that same formula and substitute it. I end up with 1 minus the probability of 0 plus probability of 1 plus the probability of 2, which is going to be 1 minus 0.100 plus 0.267 plus 0.311, which equals 0.322. And then probability of x being greater than 3 equals 1 minus the probability that x is less than or equal to 3. And again, we have that equal to the probability, equal to 1 minus the probability of 0 plus probability of 1 plus the probability of 2 plus the probability of 3. And we see that that equals 1 minus 0.100 plus 0.267 plus 0.311 plus 0.208 equals 0.114. Okay, I'll pick up later.